man. I actually don't know how to pronounce that. Deposited $100,000 into a savings account with a nominal annual interest rate of I% compounded monthly. At the end of the 8th year, the amount in the account had increased to $150,000, and for part A, we need to find the value of I being the annual interest rate. Now, a lot of you are listening to my voice right now and thinking to themselves, what the heck is going on? So, the first thing that we should be establishing right away is that this is a finance problem. Okay, there's a couple keywords, a couple key concepts, a couple buzzwords that should be jumping out at you, and you should be telling yourself, yep, this is that one finance exercise that pretty much every paper one has. And if not in paper one, for sure in paper two. So, let's just highlight what sounds important. See, that usually tends to work out. So over here, we have these 100,000s, but these were deposited. The other thing that can help for context, although a little bit less in terms of numbers, is that it's a savings account. So this is a savings problem. In other scenarios, maybe we're in debt, stuff like that. Here, we are saving our money. So that might be relevant down the road, or for understanding better how to solve it, etc. Then they tell us that we have a nominal annual interest rate of I%. So my nominal annual interest rate is I%. And they put it in bold because it is very important, compounded monthly. At the end of the 8th year, so end 8th year, keep that in mind, end 8th year, the amount in the account had increased to 150,000. And so that is the general sort of gist of it. See? So, first I'm going to show you the formula booklet, and then I'm going to show you how you should really solve it. See? I mean, not really solve it, but what I suggest. ¿Vale? So once you establish that it's a finance problem, there are two main tools that I can show you, teach you, etc. The first one, okay, is going to be going literally straight to the formula booklet. See? So formula booklet, and what are you going to find? Within the formula booklet, you will be finding, eventually, once you look long enough, you find this compound interest formula. Okay, and this compound interest formula that I'm putting now in yellow, okay, notice it has a bunch of stuff into it, but all you really need are 5 things: the future value, the present value, the number of compounding years, the number of compounding periods per year, 1, 2, 3, 4, and 5, the nominal annual rate of interest. And so guys, for all these finance problems, you need to understand that you will be given 4 out of 5 of these, and you need to find the last one. And so within this context, for part A, you need to find the value of I. I is the nominal annual interest rate. Okay, nominal annual interest rate. Nominal annual interest rate. Rate of interest, yeah, same thing. See? So basically what's happening here is that they're telling you, hey, you do not have R, but you do have K. You do have K, you do have N, you do have PV, you do have FV. And so although this might look very nasty once you plug everything in, you have to realize you have 4 out of 5. And if you have 4 out of 5, you can solve it. Okay? You can solve it. You can reach R equals something, like an actual number. See what I mean? So these exercises, you always get 4 out of 5. And your two main tools, as I was saying, is the formula booklet or the finance app. Okay, and the finance app comes forth in your graphing calculator. Now, what do I suggest? What I suggest is that you sort of visualize and remember that in the world of finance, you are working with the formula from the formula booklet, because it's also a very, very kind reminder of, hey, if you have 4 out of 5, you can solve it. These are the things it asks for. The formula looks sort of like this. It's very useful to take that approach. But the problem is you don't always use the compound interest formula in the formula booklet. Point is, for this first strategy using the formula booklet, it's not always what you're supposed to do. There are a few scenarios where this formula is actually not enough, and you have to use the finance app. So point is, the formula booklet is something you will not always have to use, okay? While the finance app always works. So, although the formula booklet might be a little bit more friendly, okay? It might be more, whatever, easier to handle, easier to come across, easier to this, easier to that. In the long run, eventually you will find exercises where you need to use the finance app. So I'm not going to show you how to solve it for the formula booklet. I will show you how it works with finance app. And now, there's probably more than one of you thinking right now, like, okay, if the formula booklet doesn't always work and the finance app always works, then what are the scenarios? What are the scenarios that make the formula booklet formula booklet? What are the scenarios that make the formula booklet not work? So the scenarios that make the formula booklet not work is whenever you have this thing that we will call PMT. And PMT, although I forget what it means, is basically going to be like any sort of monthly payment or deposit. And the main thing that's very important to understand here, that is additional to what you already pay your deposit. And notice, I haven't even entered the exercise yet, but I am giving you a lot of context of how the finance problems, how they look like in these papers, what you're going to come across, what you can expect, okay? So, the reason the finance app is something that you should prioritize over the formula booklet is because the finance app always works, while the formula booklet not always. And in which scenarios does the formula booklet not work? It doesn't work whenever you have to apply PMT. The only way in which you can apply PMT is using the graphing calculator with the finance app. Okay, what the heck is PMT? PMT is the monthly payment or deposit additional to what you already pay or deposit. Okay, and as you can see, if you just read for part B, ¿cierto? If you read for part B really quickly, here at the end it says, at the end of each month, man will receive a payment of 1,000. Which is different, okay? Which is completely additional to what he already has to sort of pay or whatever, and etc. ¿Cierto? And so if you actually go to the answer key, you can see that for number 5, here are 2 variations for part A, ¿cierto? Here are 2 variations of the graphing calculator, and there's a 3rd variation that is with the formula booklet, okay? So yes, the formula booklet does work for part A, but for part B, there isn't a version with the formula booklet because, look at that, you have PMT. So whenever you have PMT, you cannot use the formula booklet. I know this video is a little bit longer because I've been explaining a lot that context, but I think it's extremely important for us to understand that immediately. So enough blah blah, let's actually get into it from now on. See? So for part A, we need to find the value of I. So what I suggest is, of course, since we're using the finance app, get familiar with the finance app. So open up your trusty rusty calculator, make sure it's got batteries, go to apps right here in purple, press finance, it should be the only one, unless you installed Pacman or whatever, and from here, you will be using TVM solver. Okay, and TVM solver, I need you to understand, is basically like this formula in the formula booklet, but right here. And it has a variation where you can put PMT that the formula booklet doesn't have. That's pretty much it. The other thing I need to point out is that a lot of this is like easy to associate. Like PV is still PV. I% is the R that we're talking about there, ¿cierto? FV is still FV. PMT is the thing I mentioned, which for part A it just equals 0. But then you have these 2 weird things down here, ¿cierto? PY, CY, N. There's a couple different ways to answer this, and it does have to do with like periods and compounding and stuff like that. And this is n, but it's a big N, right? And so as you can see in the answer key, depending on how you approach n, and this is very, very important to understand, depending on how you approach n, it's going to change what you plug in down here. Notice, plugging in a different n changes how you plug in down there, ¿cierto? So how should I technically sort of like be answering this, or what I suggest? What I suggest is that in your calculator, see, you go for the method that is up here, ¿cierto? Prioritize the method up here. Why do I prefer the method up here? I prefer the method up here because for me, it is easier to remember that these two at the bottom are the same instead of remembering like that there's actually a difference. For me, that's easier. For other people, it's not. So I'm only going to show this strategy for the one up here. For the one up here, all you have to do is treat big N as K times N. So if big N is K times little n, then this is big N. Okay, that's the first observation I'm going to make. For me, for this method up here, ¿cierto? For this up here, you need to act, or you need to proceed saying that big N is K times little n. And the other thing you need to establish is that Py equals Cy, because they're both equal to 12, and you will treat both of them as K. And as long as you do that, you're good to go. All right, so man deposited 100,000 into a savings account. So immediately we can think, okay, it's a savings account. So initially my present value was depositing $100,000, right? And my future value, I can already establish as well. We know that it ended up being 150,000. So we can also say that it's future value 150,000. What else can we mention? We can mention that, well, the annual interest rate is actually what you're trying to find, ¿cierto? So I'm going to put this in pink so I remember this is my variable that I'm trying to find. Compounded monthly, ¿cierto? So how do you express compounded monthly over here? Well, in the formal booklet, K is the number of compounding periods per year. And so just a little bit of context, if it's monthly, how many months are in a year? 12. If it's yearly, how many years are in a year? 1. And if it's, I don't know, I mean, that's pretty much all they can ask. But maybe quarterly, you know? How many quarters are there in a year? 4. How many semesters are there in a year? 2. In my experience, it tends to be like monthly or quarterly. It doesn't go farther than that. But there are a couple variations. There you go. I know about it, but I don't know if they asked it in the IB yet. Bi-monthly, like every 2 months, would be K equals 6. See? So there you have a couple variations of compounding periods per year. Not to scare you, but those are the words you have to be familiar with. See? So compounded monthly tells me that K equals 12. And they also tell you that at the end of the 8th year. So my man deposited $100,000, which compounds monthly. And after 8 years, the amount was $150,000. After 8 years, N, the number of years. So little n is going to be 8 years, right? And as I established earlier, using the method up here, I am applying this. ¿Cierto? So if I'm applying this onto my calculator, I need to calculate big N. I know that big N is K times N. ¿Cierto? And you can actually pop that over here right away. You can literally put, for big N, you can put K times N. You can put 12 times 8. It'll do itself and leave it as 96. I% is actually what you're trying to find. So I'm going to leave it like that. See? And PV and FV has something interesting going on here. See? Point is, my man deposited $100,000 into a savings account. And so there's like two sort of perspectives you can take here. Okay? Just to explain a little bit the mark scheme here. You have two perspectives. So you have the perspective, POV, ¿cierto? Point of view, of my man. Or you can take the perspective point of view of like the bank. See? So if you take the I think understanding the bank is a little bit easier here. See? So if you take the perspective of the bank, initially they get $100,000. ¿Cierto? And then the bank does bank stuff, they enjoy the money, etc., whatever. And the moment that my man takes away his money, the bank proceeds to lose $150,000. So this right here is one alternative. Okay, you have a positive PV but a negative FV. While the perspective of my man, ¿cierto? Which I'm going to be putting over here with whatever, purple. See? So the perspective of my man is that from his pocket, he deposited $100,000 into the savings account, ¿cierto? So initially, my man just lost $100,000. So it's a negative $100,000. And when he goes ahead and takes the money out of the bank, he earns back $150,000. So notice, in the two scenarios, you either have that PV is negative and FV is positive, or you have that PV is positive and that FV is negative. It's one or the other. You have to pick a perspective. It does not work if you leave both as positive. Okay, it's not going to work, and I'm actually going to show you. See? So you have to take these different sort of symbols. If you make them both positive, it's not going to work. I'm going to show it to you. That is why in the mark scheme over here, you have these really weird symbols. Okay? All this is really saying is that they're both either positive or negative, but because one of them is flipped, it's basically saying like, oh, okay, so if this one's positive, then the other one has to be negative. That's why it's flipped. It's like the two scenarios. See? Anyways, a lot of blah blah in this case, but probably one of my best videos explaining finance. See? A lot of context, but I'm sure some of you needed it. So now I can go ahead and plug in. I'm going to be taking the perspective of, I'll take the perspective of my man. So my man lost $100,000 initially because he put it into the bank. PMT is 0 because there isn't any additional monthly payment. And FV, the money he gets back, is positive $150,000. And this, we said we were going to treat it as K, both of them. ¿Cierto? So you go ahead and pop 12 into both. Why is it 12? It's 12 because it's compounded monthly, and K, as we said, is number of compounding periods per year. We are in this scenario right over there for part A. Yeah. And so from here, well, you plugged everything in. How do you solve for I? How do you solve for I? Solve. There's a solve button right here. And basically what's going to happen is that you're going to press that solve button and you will be telling your calculator, hey, using these parameters, all these numbers I'm putting out here, tell me how much this should be. And so you press alpha, you press enter in order to hit solve, and boom, there's the percent. So basically, if you have a big N of 96, and a PV of this, and a PMT of that, and an FV of this, and a PY and a CY of that, given all of that, your percent, your annual interest percent should be this. And if we check the mark scheme over here, it looks pretty correct to me. So for part A, that's pretty much your process. Notice that it is worth 3 points, and so if it's worth 3 points, show your work. This right here was showing my work. ¿Cierto? That is showing my work, and then you get actually it's a method point and an answer point, like plugging it in correctly or whatever, ¿cierto? And then it's a whole other point to just write down the answer. See? So I has to equal, for part A, I equals 5.07%. Actually, if you do significant figures, you count 1, 2, 3, round it up or keep it the same, you round it up. So it's actually 5.08. All right, now after all of that context, part B should be a little bit faster. See? Unless it gets incredibly hard, which we are about to find out. So we have that my man, withdraws the $150,000, okay, and places it in an annuity, earning a nominal annual interest rate of 6.1% compounded monthly. So immediately we already have a percent. We already know that it's compounded monthly. And additionally, at the end of each month, my man will receive a payment of $1,000. See? So this additional sort of payment thing means I have a PMT of 1,000. And we need to find the amount of money remaining in the annuity at the end of 10 years and express your answer to the nearest dollar. And so if we look over here a little bit to understand the context a little bit better, just to remember how to solve this, because I'll be honest, I didn't remember too well, but the most important part is explaining how it works, ¿cierto? So yes, I did sneak peek the answer, but I'm just trying to understand and explain it more properly. For part B, this is what's happening. Dale? Basically, for part B, yeah, it's very important that you either always go for the perspective of the person or the perspective of the bank. Dale? And in this context, for me at least, it makes a little bit more sense to take the perspective of the man, of my man, ¿cierto? So, he withdraws the $150,000, so for a moment he earns it back into his pocket, but then immediately places it in an annuity. So, PV has to be negative. It's like, yes, it went back into his pocket for a moment, but boom, he put it back into an annuity. He lost that money. So PV equals negative 150,000. And when they tell us that we earn a nominal annual interest rate of 6.1%, so I can already establish that I percent has to equal 6.1. All right, what else can I establish? It's also compounded monthly, so K does have to be 12. And at the end of each month, my man will receive a monthly payment of 1,000. So PMT, 1,000. And because it's the perspective of my man, we have a PMT equals positive 1,000. See? Find the amount of money remaining in the annuity at the end of 10 years. Okay, this is another interesting thing. For part A, all my variables were within that initial paragraph. For part B, one of my variables was hidden in the question, or what they ask you to find. When it says 10 years right there, n equals 10. And so look at that. This is pretty much it, ¿cierto? When it says find the amount of money remaining at the annuity at the end of 10 years, that is after a while, ¿cierto? That is later on. That is in the future. So the future value is actually what you're trying to find here. See? So in this context, big N, ¿cierto? Has to be K times N. So we can say that big N has to be, actually, let me like put, I like to do this, it's a personal thing. Put 0 on everything. Just to like, well, I think here you have to put 1. Just to like start from fresh. So starting from fresh, big N has to be K times N, because we are employing the strategy up here, which is basically just this. Big N has to equal K times N. PY equals CY equals K. So big N has to be 12 times 10. This 12 times that 10. 12 times 10. I percent, they gave it to us earlier. 6.1. What else? PV, ¿cierto? PV is negative 150,000 right there. Because my man lost money out of his pocket. PMT is 1,000 because my man is earning that 1,000, ¿cierto? He receives that payment of 1,000 each month. FV is actually what we're trying to find, and these last two, as we said, have to be K. See? So these last two have to be K. K is 12, so go ahead and put 12 on both. Yeah. And so from here, I can just solve for FV. So alpha, enter to hit solve. There is my value for FV. And so the amount of money remaining and the annuity at the end of 10 years for part B has to be that number. See? So let me write that number real quick. 866.7064. Now this, ladies and gentlemen, if you box it in as your final answer, is actually not good enough. And it's not good enough because here they tell us to express your answer to the nearest dollar. And so we're expressing it to the nearest dollar. Basically, you need no decimals. And so you have to evaluate, do you round this number up or down? I mean, up or keep it the same. This is 5 or above. It's at 7, ¿cierto? So 7 is above 5. You have to round it up. That means you end up with your final answer is 110,867. Is it dollars? Yeah. Just the dollar sign is fine. See? Boom. So that is our answer for part B. And the last thing that I forgot to mention earlier, and with this I will probably end the video, is this guy here, ¿cierto? I did tell you for part A that it has to be opposite symbols, the positive and the negative, ¿cierto? You either take the perspective of the bank or the perspective of mom man. And if you don't do it that way, you're gonna run into trouble. Let me show you how that trouble looks like, okay? Because it might happen to you the day of the test, and you do have to know how to react. So, if I were to keep them both positive, what happens? Well, you would end up with a big N of 96. I% is actually what you're trying to find. So here, I'm going to leave them both positive, ¿cierto? So this is back to the context of part A, just to show you if you leave them as both having the same symbol. And if you go ahead and solve from here, you literally, it says error, no sign change, okay? And this is happening basically because you either take the perspective of my man or you take the perspective of the bank. There is no other. What I suggest is that you pick one of them, get familiar with it, and always employ the same one, okay? All you really have to change is PV and FV. I think there are scenarios where they are the same symbol, but in my experience, almost always with one perspective over the other, you should be good to go for like all exercises. See? PMT, I always see it with end, ¿cierto? And I don't think that's going to matter to you ever. But here it does says at the end of each month. So if you really want an argument for that, there you go. See? So PMT is end because there it says at the end of each month. Ladies and gentlemen, enough blah blah. That was a long explanation, but a very needed one for some of you. So this one's for you. In my case, at least, happy Monday, and I'll see you around.